Welcome to Cognito Key. Ever stop and wonder how all your sensitive data, I'm talking bank details, private messages, everything, is kept safe from prying eyes? Well, it's all thanks to this really clever trick called a block cipher, and today we're going to unlock its secrets.
So, here's our game plan. We'll kick things off by breaking down what a block cipher even is. Then, we'll get into the secret sauce that makes them so powerful. After that, we're going to explore the different modes they can operate in. You can think of these as different strategies for keeping your data locked down tight. All right, first things first. Let's really get a handle on the core concept of a block cipher. You'll see it's all about taking a massive task and making it way more manageable.
Okay, imagine trying to read a whole book, but only one letter at a time. It would be incredibly slow, right? Well, a block cipher is like reading in complete sentences, or blocks. It grabs a chunk of your data, say 64 bits, and encrypts it all in one single go. This makes the whole process so much faster and way more efficient.
And this really shows you the key difference between block ciphers and their cousins, stream ciphers. Stream ciphers are doing that slow, one bit at a time thing, but block ciphers? They work in these big chunks, which makes them perfect for the high-speed demands of all our modern computers.
So what's the secret to making a block cipher really strong? It's not just about having some super complex algorithm. Nope, it's actually about a careful mix of three key design principles. Let's take a look.
These three things are basically the building blocks of a secure cipher. Think of it like a puzzle. The function f is your core puzzle piece, and the key schedule is the set of instructions on how to put it all together. And the number of rounds, that's just how many times you scramble the puzzle. The amazing part is, even if your core puzzle piece is kind of simple, scrambling it over and over and over again makes it incredibly difficult for anyone to solve without the key. Okay, now that we've got the theory down, let's see how this stuff actually works in practice. We're going to start with the simplest mode of operation out there, the electronic codebook, or ECB. But as we're about to find out, simplicity can sometimes be a double-edged sword.
It's really straightforward. You take a block of your text, you encrypt it with a key. Then you take the next block and you encrypt it with the exact same key. You just keep repeating this process for your entire message. Simple, right?
Well, here's the catch. If your original message has repeating patterns, like the same word showing up over and over, those exact same patterns are going to show up in your encrypted text. And that, my friends, is a major security flaw, because it gives attackers big clues about the structure of your message.
And yeah, that's a huge problem. This information leakage is kind of like leaving a trail of breadcrumbs for a hacker to follow. They can just analyze those patterns in your encrypted text to figure out the structure of your original message, even if they don't know the key. That's exactly why ECB is a big no-no for anything except really short, random data.
So how do we fix this whole pattern problem? The answer is this really clever technique called chaining. And this leads us to our next mode of operation, Cipher Block Chaining, or CBC, which is a total game changer. So here's the magic of CBC. Before encrypting each block, you mix it with the encrypted version of the block that came right before it. What does this do? It means that even if you have two identical blocks of text, their encrypted versions are going to be completely different. It's like you're adding a unique secret ingredient to every single block, and that just completely hides any repeating patterns.
Now, CBC is just one of many modes. There are a bunch of others, and each one has its own strengths and weaknesses. For instance, CFB, or Cipher Feedback, that's great for encrypting data in real time, like a video stream. Then you've got OFB, Output Feedback, which is designed for situations where data might get a little corrupted, because an error in one block won't mess up the whole message. Encounter mode? That's all about speed, making it perfect for high-performance stuff.
So you might be asking, why are there so many different modes? Why not just pick one? Well, it's not just about having options. It's about understanding a really crucial lesson in cryptography that can literally make or break the security of your data.
This quote just hits the nail on the head. I mean, you can have the most powerful lock in the world, but if you leave the key under the doormat, it's totally useless, right? It's the exact same for encryption. A strong algorithm is only as good as how you use it. If you choose the wrong mode, you can leave your data wide open, no matter how strong the algorithm is.
And that really brings us to the future. As we generate more and more data, and as cyber threats get more and more sophisticated, the way we encrypt our data is absolutely going to have to evolve. It makes you wonder, what new modes of operation will we need to invent to keep our digital lives safe in the years to come?
I hope you enjoyed this little journey into the world of block ciphers. If you'd like to unlock more secrets of digital security, please be sure to like this video, share it, and subscribe to Cognoto Key. Thanks so much for watching, and stay curious.